Good day, everyone. Today, I'm thrilled to dive into a topic that powers our world and drives innovation: fuels. From the gasoline in our cars to the renewable energy sources shaping our future, fuels play a critical role in our daily lives and the environment. So, let's ignite our curiosity and explore this fascinating subject together. Before we will dive into the content, these are the things that we will be discussing about the fuels, starting with the introduction to fuels, the properties of fuels, then the coal and gas, and lastly, the principle and combustion. Fuels are vital resources that play a central role in our powering our daily activities and industries. These energy-rich substances are used to generate heat, light, and power, enabling essential processes in transportation, electricity production, and heating systems. By understanding fuels and their application, we can better appreciate their impact on our lives and explore ways to use them efficiently while moving toward sustainable energy solutions. These are the pictures that show the different types of fuels. Fuels can be classified into different types based on their forms and origins, with coal, oil, and natural gas being the most common examples of fossil fuels. These fuels are derived from the remains of ancient plants and animals that have been subjected to heat and pressure over millions of years. Number 1 is coal. Coal is a solid fossil fuel formed from the remains of ancient vegetation. It is primarily used in power plants to generate electricity and in industries for producing steel and cement. Example: bituminous coal is commonly used for electricity generation, while anthracite coal is used for heating due to its high energy content. Number 2, oil. Oil or crude oil is a liquid fossil fuel that is refined into various products such as gasoline, diesel, and jet fuel. It plays a critical role in the transportation and manufacturing industries. Example: gasoline is used in cars, while kerosene is used in jet fuel in airplanes. Number 3 is natural gas. Natural gas is a gaseous fossil fuel composed mainly of methane. It is widely used for heating, cooking, and electricity generation. It is also considered a cleaner alternative to coal and oil because it produces fewer emissions. Example: compressed natural gas is used as a fuel for vehicles and liquefied natural gas is used for power generation and industrial heating. These fuels have powered human development for centuries, but their environmental impact has prompted a shift toward more sustainable energy resources. The properties of fuels refer to the characteristics that determine their efficiency, usability, and environmental impact when used for energy production. These properties help in selecting the right fuel for specific applications and understanding its behavior during combustion. So here are the key properties of fuels. Number 1 is calorific value. This refers to the amount of energy a fuel can release during combustion. A higher calorific value means the fuel can produce more energy, making it more efficient. Example: hydrogen versus coal. Hydrogen has a very high energy content of about 120 mJ per kilogram, meaning it produces a lot of energy when burned. It burns cleanly, releasing only water. Coal. Its energy content depends on the type, with anthracite with a high quality coal around 30 mJ per kilogram and lignite low quality coal around 15 mJ per kilogram. Burning coal releases more pollution compared to hydrogen. Hydrogen produces 4 times more energy than coal per kilogram and is much cleaner and a better fuel for the future. The flash point is the lowest temperature at which a fuel can give off enough vapor to catch fire. Example: gasoline. Flash point is about -43 degrees Celsius. This means gasoline can catch fire easily even in every cold weather. Because of this, gasoline is useful for cars but must be handled carefully to avoid accidents. Unlike to gasoline that even the lowest temperature, it can easily give off vapor which can easily catch a fire, whereas in an ignition temperature, a very good example for this, a diesel, are less likely to catch fire quickly, making them safer to store because it has a higher ignition temperature. The density of a fuel refers to how much mass it has in a given volume. Fuels with a higher density have more energy stored in a smaller space, making them more efficient in certain applications. Example: diesel. Diesel has a higher density than gasoline, meaning it packs more energy into the same amount of fuel. This is one reason why diesel engines are more fuel efficient for heavy-duty vehicles like trucks. Gasoline. Gasoline has a lower density than diesel, which means it provides less energy per liter but is a lighter and more suited for lighter vehicles like cars. In general, fuels with a higher density provide more energy for the same volume but may be heavier and more challenging to handle. When we say viscosity, it refers to how thick or sticky a liquid fuel is and how easily it flows. An example of this is crude oil versus gasoline. Crude oil has a high viscosity, meaning it is thick and flows slowly, while gasoline has a low viscosity, meaning it is a thin and flows easily. This properly makes it ideal for use in car engines where it needs to move smoothly through fuel lines and injectors. In short, crude oil is much thicker and harder to flow than gasoline, which is lighter and flows easily. Coal and gas. Coal is a solid fossil fuel primarily composed of carbon, hydrogen, sulfur, and other elements. It is formed from the remains of plants that lived millions of years ago. Coal, it is classified into types such as anthracite, bituminous, subbituminous, and lignite based on carbon content and energy density. Coal. Example: anthracite coal has the highest carbon content and calorific value, making it more efficient for heating purposes. However, it is less abundant compared to lower grade coals like bituminous coal. The principles of combustion. Therefore, combustion is the process of burning a fuel to release energy in the form of heat and light. It happens when a fuel reacts with oxygen, usually from the air, and produces energy. Example: burning wood. When you light a piece of wood, the heat causes the wood to react with oxygen in the air. This reaction releases energy creating heat, which warms you and lights the flame you see. The wood turns into ash and releases gases like carbon dioxide. In simple terms, combustion is like the burning reaction that happens when a fuel like wood, gasoline, or natural gas combines with oxygen to produce heat and light. Complete combustion, meaning this occurs when there is enough oxygen for the fuel to burn fully. It produces only carbon dioxide and water which are clean and safe, just like the example when natural gas is burned in a well-ventilated environment. It has sufficient oxygen to produce just CO2 and water vapor, making the process efficient and less harmful. Incomplete combustion. This happens when there is not enough oxygen, causing the fuel to burn partially. It produces harmful byproducts like carbon monoxide and other pollutants. For instance, burning wood in poorly ventilated stove limits the oxygen available, resulting in the release of CO2, a toxic gas that can be dangerous if inhaled. Conduction. A metal pan on a stove gets hot because heat travels directly from the burner to the pan. When you touch a hot handle of a cooking pot, heat transfers to your hand through direct contact. Number 2, convection. The warm air from the fireplace spreads heat throughout a room as the hot air rises and cooler air sinks. Boiling water, heat moves from the bottom of the pot to the water, causing it to circulate and heat evenly. Number 3, radiation. Feeling the warmth of a bonfire on your face even though you're sitting a few feet away. The sun's heat reaches the earth through radiation, traveling as electromagnetic waves. That's all for today. Thank you.